Assalamualaikum and very good morning. Sorry, good afternoon. So this is our first class, chapter 1. Okay, so they are regarding about the water quality. Okay, so what is the water quality? How we can know and how we can justify, identify, categorize that the water quality is the good, worse or polluted. Okay, so in this chapter will be know what is the indicator or what is the criteria that is required to know the level of the water quality of the surface water. Okay, so here is the subtopic in the water quality. So what is the water quality? The standard that we use to identify, categorize that the water quality. Okay, so the parameters, okay, is instead of the physical, chemical, biological, the sampling, river monitoring, and DO cycle. Okay, so beneficial water users. Okay, water will be used for the municipal, agriculture, industrial, rural. So all of you, all the activities, okay, instead of the industrial, domestic, for the human, all of we rely on the water. So the water is the main the important component in the life. Okay, water resources. So I know all of you know where is the water come from. Okay, so it's sources from snow, rain, surface water. Okay, so water from the watershed. Watershed that means rainfall fall into the surface and all the gather in the watershed. We had a lake, okay, river, reservoir, groundwater. Okay, groundwater will be composed of the subsurface water or groundwater. It's fresh water located in the pore space or soil and the rocks. So in topic of the groundwater, kita ada elective. We had the elective course for the groundwater. So for the groundwater, they has a specific course in the elective in 4th year nanti. If you want to know about the groundwater, so you can join that the elective courses, elective course. Okay. So groundwater is flow within the aquifer below the water table. Okay. Desalination is the sea or ocean. Okay. Saline water is convert to the fresh water. Here we not use the saline water. We still have the bundle, okay, use quantity of the surface water. So we very lucky in Malaysia we have this more surface water until so every month, every day, every month, okay, we have the flooding case, okay, because we have a lot of the water surface. Okay, water quality definition is the technical terms that be open the characteristics of the water in the relation to the guideline value or what is suitable for the human consumption and for all as usual domestic purpose. So this is the definition of the water quality. We know the standard, okay, or level or baseline. Okay, what is the baseline that we need to comply? That means we can use for the human consumption. Okay, better if for the human consumption, the level or the baseline for the water quality must be stringent, must be have the low pollution, a low quantity, low pollution concentration ataupun accessible, okay, permissible, okay, ataupun yang boleh kita guna, okay, for the human consumption. For the domestic ataupun for agriculture ke, for the aquaculture ke, maybe they have the own level. What is the level? Maybe certain for the agriculture, they need to look at the type of the fish. Okay, sometimes the fish have sensitive fish. So sensitive fish, they have the most stringent standard. So you cannot use the simply water. So maybe they have the good water level pH must be alkaline ke, natural ke. Okay, no any contamination of the heavy metal. Okay, turbidity must be at a certain level. Okay, so the water quality ni depend on the purpose. Okay, the purpose for the human, for the agriculture. So the objective for the water quality, to control the discharge of the pollutant so that water quality is not degrade, okay, to an unsuitable extent below the natural background level. Okay, dia mesti on the baseline. Okay, baseline. What is the baseline of the certain water? So kita mesti comply dengan baseline. Tak boleh terlampau rendah ataupun over that the baseline. Okay, water quality parameters are the natural and man-made chemical, biological, microbiological, and characteristic of the river, lakes, and groundwater. It provide important information about the health of the water body. Okay, are the natural and man-made chemical, biological, and microbiological characteristic of the river, lakes, and groundwater. It provide important about the health. Okay, ni repeated sama je, atas bawah ni sama je. I used to find out if the quality is good enough for drinking water, recreation, irrigation, and aquatic life. So this is important. We to know the water quality parameters. Okay, so they have the two type of the water pollution. Okay, where is come from? Water pollution. So we can generalize in the two terms. So is the point source, and the second one is non-point source. So the point source, that means the pollution flowing from the single and identifiable source, such as discharge from the pipe, from the factory, roadway, or leaking underground storage tank. Okay, kita can be identify where it's come from. Okay, that is we call as the point source. Okay, for the non-point source pollution collected by rain atau stormwater falling over the large watershed, which is then carried by the runoff to a nearby lake or stream, or by infiltration into the groundwater. So yang flushing tu, hujan flush the runoff on the surface. So the runoff atau we call it the storm water. Okay, storm water tu on the surface, on the earth, and then they wash, they carry with all the pollutant on the surface, bring out and go flowing to the lake, stream, or nearby water bodies. This we call as the non-point source. Okay, this is the features for the point source. So we know where is the point. Okay, here from the pipe. So we know the pipe, sewerage pipe. Okay, from the pipe we can identify. So this is the point, have the point. So they are point. Okay, known. Now we known. We known, and this is okay. Kita boleh determine what is the point source. Okay, so this one, this figure we can nampak dia punya okay, the pollution, the discharge, the pollution here. So we tahu they come out from these activities. Okay, this is the point source pollution. Okay, for point source pollution, so what is the description? Hazardous and toxic material from the manufacturing industry discharge directly into the water, usually to the pipe or leaky underground tank. Okay, ataupun or in the certain activities, like say for poultry ke, okay, the washing atau the wastewater, they not through any water treatment. Okay, let's say we have the poultry, this activity poultry. Okay, so the water uses for the poultry should be going to the wastewater treatment. Okay, but sometimes they don't install or construct for the wastewater, tak ada. No, here they directly discharge to the river. Okay, this is some of the point source of the pollution. So for the parameter, let's say oil and gasoline, solvent, toxic, poison, heavy metal. Okay, thermal pollution ni the temperature of the water is the high. Okay, high temperature of the water. So the heated water can be cause the dissolved oxygen content in the body water decrease. Okay, bila DO decrease, so dissolved oxygen in the water less, so they will kill the aquatic life. Okay, so what is DO ni kita akan discuss lah in the detail we can discuss in a DO set curve. Okay, DO set curve we will discuss about the level of DO from the acceptable level to the toxic level. Okay, this is non-point source. Okay, non-point source, rainfall. Okay, so rainfall, so rainfall go to the surface and the flow. Rainfall, okay, run off, so dia jadi run off, dia become as the run off here, run off, go to the any certain area, certain city ke, rural area ke, development area ke, okay, feedlot, okay, and crop. So without any point sources, so we call as the non-point source pollution. Okay, kalau feedlot ni dia ada pipe, ada saluran air, longkang sini masuk, they have the drainage masuk this one, so this one kita not call as the non-point. Okay, this one kita call point source because we know they come from the feedlot. But if the feedlot without any channel, okay, channel or stream that flow the wastewater to the river, so we can categorize as the non-point source pollution. Okay, so non-point source pollution is harder problem to solve because we cannot identify where it's come from. Okay, whether it's from suburban development, city street, rural, or at the animal feedlot. Okay, we cannot identify the exact location, sources of the pollution. Okay, that is the harder problem to solve. Okay, this is the non-point source pollution, the changing urban landscape. Okay, let's say we have the undevelopment area and development area. So let's say this one kawasan area non-development, this one development area. Okay, so when the rainfall, so almost 40% of the water will be evaporate. Okay, and 20% will be infiltration and 25% is shallow infiltration. Okay, this is the in the non-development area. So only 10% become as the runoff. So the small proportion of the rainfall become the runoff. So when the small, so the quantity of the pollution carry out with the runoff will be less. Okay, will be less because 10% saja. Okay, however, when you look for the development area, okay, because we less of the tree, okay, grass and green area, so only 30% transpiration. So only 3% of the rainfall, volume of the rainfall is the evapotranspiration, and 10% going to the shallow infiltration, and 5% going to infiltration. This is due almost 70% and 100% is the impervious cover. So kat sini here, layer here, semua impervious. Road, concrete slab and so on is the impervious cover. That's why only small quantity of the rainfall can be infiltrate into the ground. Okay, and the rest almost 55% of the runoff. This is the typical value, percentage. Okay, proportion of the rainfall going as the runoff. Okay, when 55% runoff in the development area, so here a lot of the pollution on the surface. Okay, a lot of the pollution on the surface here. Bangunan ni ada surface, ada pollution. Okay, bumbung ada pollution, is it? So ada like burung ke apa ke so on kat permukaan jalan ni. So from the road car, okay, road car they have the emission, okay, the emission of the CO2, monoxide, okay, your tires, the car tires, so getah tu the rubber, so material permukaan ni, a lot of the pollutant accumulate on the surface. So when the high volume of the rainfall become as the runoff, okay, so they will be swept out all the pollution on the surface, go to the river, okay, go to the stream, go to the lake. Okay, that's why the non-point solution is the challenging. is the challenging, that is the challenging to solve it. Okay. Okay, by water falling, so this one they discuss. So all this here, let's say the gas, oil, chemical, detergent, phosphorus on the surface, okay, on the roof, on the road, and so on. Okay, I can flow through the stormwater and release to the water bodies without untreated. Okay, without untreated. If the point source, we can know that is the point source, so we can handle it by treated the wastewater before we discharge into the water bodies. But for the non-point sources, they have the challenging because we don't know, and a lot of the water. Okay, so the bertebaran, okay, the whole area, wide area, so they sweat out and go to the water bodies. Okay, this is the example of the urban watershed. Okay, so dari sini air hujan, okay, air hujan turun, okay, go to the gutter piping, side piping, okay, go to the nearest drain, shower, okay, and then go to the nearby water body. Okay, so this one adalah stream, okay, stream, and then this stream finally go to the ocean or stream lah, ocean stream. So this system no treated, okay, untreated. The wastewater, the sweat, all the pollution here, the longkang apa, drainage ni, semua akan go to the nearby urban stream and then go to the ocean or the stream. Okay, that is a lot of the sources of the pollution will be bring together with the runoff. Okay, instead of the urban area, so modern farming is the major source of the non-point sources. Okay, pesticide, okay, the application or the uses of the pesticide, herbicide can wash into the nearby lakes and the water. Okay, crop field, especially after harvesting, can wash large amount of dirt and the sediment into the neighbour lakes and river. Okay, contoh for the area, let's say here adalah area kawasan paddy, okay, paddy plantation. Okay, when crop field, when you yield the hasil, you crop the crop, you yield the hasil, so all here become as the open area. So no more vegetation here. Okay, no more vegetated here. So bila open area, only open area with earth area, okay, exposed for earth. So when the rainfall go to the paddy plantation, paddy farm, so all this sediment will be go to the nearby river. So here, so accumulation of the sediment here and apa saja yang present on that surface, okay, on surface. So they bring here. Okay, so animal waste and manure can be source of the nutrient and harmful bacteria. Okay, fertilizer can be source of the nutrient such as nitrogen, phosphorus, okay, and the nearby lake and river lead to the serious problem of the eutrophication. So eutrophication, that means the algal bloom, also we know as the algae bloom. So accelerate, okay, accelerate the algae grow. Okay, if you have the highest atau excessive amount of the nitrogen or phosphorus, will be accelerate the growth of the algae. So algae tu akan banyak sebab nutrient dah banyak situ, so makin sihat lah. They very have the helpful and the growth will be increase. Okay, bila dah increase, so banyak, a lot of the algae on the water. So when a lot of the algae on the water, so nanti you nampak at a certain area tu, you look, the lake become the green. Okay, the green. So if the lake, the surface lake become the green, that means higher of the nutrient content on the lake, so they become the eutrophication. Eutrophication will be block the sunlight, and then when block the sunlight, the DO inside of the water will be reduced. So bila dia reduce, so dia boleh kill off the aquatic life and so on lah. Banyak lah, dia macam, they will be have the domino effect. Okay, domino effect. Okay, kesan first sources is the excessive amount of the nutrient, and then accelerate the algae, and the algae will become the bloom, and a lot of algae on the lake, the block of the sunlight. Okay, so the aquatic life so fish all day cannot be good have the not have the sufficient DO in the water. Okay, so here I mentioned here, the bigger farm equal to bigger problem. If you have the bigger farm, bigger problem, because you open the bigger area, so the non-point source become as the bigger. Okay, so if you have a lot of the non-point source pollution, so you quite difficult to tackle all the problem. Okay, clear cutting tree. So this one common for the pembalakan, for the timber, for the timbers, and mining construction site. Okay, mining or construction site can be major source of the non-point source. Usually for open site, as the civil engineering, kita open site, construction site, open, clearance of the tree. Okay, clearance activities. So sometimes we have the boot of the sediment pond. Okay, but when you open the area, so when the rainfall, automatically the source of the non-point source of pollution, automatically it can be as a non-point source pollution. Okay, so without tree plants in the field, hold the soil in the place, large amount of dirt and sediment, the sediment will be carried out, and then maybe they go to the nearby lake or stream. Okay, it depends on the surface. If the mining activity, of course they have the heavy metal doing, they use the oil. Okay, for the pumping, for the mining. Okay, they have the oil, and then maybe that's all will be flush washing through to the water bodies. Okay, so we already know what is the source of the pollutant. Okay, there you can form the point source or non-point source. So how we can understand, to know how we can know that the water is the good. Okay, so that's why we need to in the certain, or in each country or every country, they have their own water quality standard. Okay, what is the standard? Standard piawaian, standard, that means the level standard. So we know. Okay, contoh, the easy contoh for the standard, the standard tu, that mean uniform. Okay, uniform, seragam, standard. So let's say baju, we have the shirt. So how we know the standard baju ni macam mana kita nak tahu kan? Orang berbadan besar nak pakai macam mana? What the big body, how we can identify, clarify the standard shirt for the big body or small body, thin body. So without standard, we don't know which type, which size for that certain body. Okay, for the body, maybe that's why we have the standard for the shirt or trousers. So they have the standard, so they call as the size. Okay, size X, S, M, L, XL. So X, M, L, S, we in the technically is the standard. M macam mana? Where is M? M besar macam ni. XL macam mana? XL untuk besar ni. S small. Okay, the size to S, M, L, XL, this is we call as the standard. That is the easier way to know what is the definition of the standard. Okay, similar to the water quality. So water quality also have the standard. So from the that standard, so we know that the water can be safe to use or not. Okay, so in the Malaysia, we have the interim national water quality standard, INWQS. Okay, INWQS used for the classification of the river or river segment based on 5 classes of the water quality. Okay, INWQS help DOE to identify problem area and develop appropriate strategies for the water quality management. It's important to maintain the high quality level for the natural water. Therefore, the DOA has set up the minimum quality standard that reflect its beneficial users. Okay, dia dah set up lah kat mana quality standard diperlukan for the certain users. Okay, so this is the network ataupun persamaan relationship between the relationship to develop water quality standard. They depend on the anti-degradation criteria and beneficial users. Okay, this is the interim water quality standard. Okay, here we have the parameter. So parameter, what the parameter that you will be determined. Okay, ammonia nitrogen, BOD, COD, DO, pH, color, conductivity, okay, floatables, odor and so on lah. So you boleh baca. So they have the 5 class. Kelas 1, kelas 2, kelas 3, kelas 4 and kelas 5. They have the 5 classes. And class 2 dia divide by 2, class 2A and 2B. Okay, so this is the range. Okay, concentration allowable. Okay, the allowable. If more than 0.1, dia akan become as the class 2A. Okay. Okay, ni temperature, total coliform and so on lah. This is the standard water quality. Okay, this is the classification. Okay, this is the parameter that you will be used to measure index water quality index. For the water quality index, they have the 6, okay, 6 parameter that you use to determine the water quality index. This is the classes 1, 2A, 2B, 3, 4, 5. So apa? Ni untuk irrigation, ni untuk water supply. So what is the suitable for the each water quality? Okay, so this is water quality index yang I refer tadi. So this parameter will be used to calculate the water quality index. Okay, so and the quality index, so we can identify whether the stream is the clean, slightly polluted or polluted. Okay, so that the class. So WQI between here, clean, slightly polluted and polluted. For the class, this is the larger than more than 92.7, the index more than 92.7, so we can categorize in the class 1. So between this range can categorize as class 2 and so on lah. Okay, based on international interim national water quality index. So this one based on index WQI. So kita boleh clean, slightly polluted and polluted, but when you relate to the NWQS, so we can identify whether the water quality in the class 1, 2, 3, 4 or 5. So we know lah what is the suitable uses for the each water quality. Okay, so in this topic, okay, in this index WQI ni we will discuss detail in the chapter 2. Okay, water quality parameter. Okay, tadi we already know what is the water quality standard, pollution. Okay, where is the sources of the pollution, from the point source, from the non-point source. So now we proceed for the parameters. Previous standard you have learned, you have USC. Okay, here you can see here. Okay, here ada parameter. So they have the parameter. So a lot of the parameter listed here. Okay, they listed here. So ada banyak lah. Okay, untuk water quality ni they have the thousand of the parameter, ribuan. Okay, so water quality in this our course we just focus for the physical, chemical parameters, chemical parameters and biological parameters. Okay, so why important to know water quality parameters? Kenapa kita tu kena tahu? Nah, apa parameter quality ni is very important to know. Okay, first of all, that is related to the point source. Okay, point source and non-point source. So let's say as you seen in the figure, so in this area, so they have the development area, okay, here the development area, okay, still have the green area, okay, maybe this one island. So in this development area they have the factory, okay, residential, this one tree, okay, they have the housing, okay, so ada mall and so on lah. So all these activities will be contribute pollution into the stream, okay, into the stream. But so when we want to analyze the water quality here, okay, when we want to analyze the water quality here, what the parameter that we need to measure? What the parameter we need to measure? Okay, if we want to follow the standard, okay, standard they have, let's say they standard ada six parameter, but let's say here have the heavy metal punya industrial, so they have the mercury ke, ada cuprum, manganese, let's say they have the type of the that parameter inside of here. That is applicable, that is relevant to use that standard to identify the water quality in this stream. Offshore is not suitable because the standard or the water quality index just only comply 6 parameter. Okay, COD, BOD, not include the heavy metal. Maybe from the 6 parameter we measure that as the good, the river is the clean. But when we measure for the heavy metal, because they have the heavy metal industry there, so they release the heavy metal into the stream. So when we measure for the heavy metal, and then the concentration have the high, okay, they have the high concentration of the heavy metal. Okay, so standard and parameter, so both of standard and parameter must be have the good relationship. Okay, so that's why we need to know the water quality parameters, because we can identify which possible parameters that we present, okay, that we present on the water or on the stream. Okay, let's see. Okay, this is typical textile wastewater. Okay, textile wastewater. Okay, they have the pH, COD, SS, ammonia, phosphate, sulfate. Okay, this textile water. Maybe here dia tak masukkan color, should be have the color. So they have the color. So from the textile wastewater activities, so they have the this is the main parameter, okay, from the textile wastewater. Okay, let's say we have the slaughtering process. This is slaughtering process. Okay, so what is the parameter that we need to measure? Okay, takkan 1000 parameter kita nak ukur. That is possible that is impossible lah. We want to measure all the parameters yang kita tahu kita kena ukur. No, tak boleh. So kita must be know what is the sources of the pollutant. What is the sources pollutant? So from the slaughtering process, so dia ada darah, ada apa, so dia maybe akan libatkan organic. So we need to find the organic, lemak apa semua, fat and so on. So dia akan libatkan oil and grease activities tu. So ada activity grease. Okay, so nutrient apa daripada pemakanan sembuhan dia, so dia comprises of the nutrient. So benda-benda tu yang kita kena ukur. So SS, bulu ke apa semua, bulu ayam apa semua, so dia ada suspended solid. Ni semua solid lah. SS kan, boleh tie apa semua, dia solid. That's why we need to know the water quality parameter, because based on the certain activity, so we can identify which parameter relevant with that process. Okay, so slaughtering, perlukah kita ukur that is necessary we measure for the heavy metal here. Tak perlulah, sebab this activity never involve any heavy metal punya releasing of the heavy metal. Tak ada libatkan, not involve the heavy metal. So tak perlulah kita measure the heavy metal because there is not the main parameter in this process. Okay, boleh tak clear, boleh faham tak? Sebab tu pentingnya we know the water quality parameter. So daripada satu aktiviti kita dah tahu, oh we need to measure ni. Okay, contoh air sisa in our house. Okay, air sisa after you pass urine, okay, bowel open, after you on biological need, settle of the biological need, so ada fecal apa semua tu, so you know. So the main parameter yang involved in your sewerage adalah organic. Okay, organic. So organic daripada pembuangan, bowel opens, okay, you buang, so dia ada organic. So organic, what is the parameter that you need to measure for the organic? COD, BOD. Okay, and then urine. Okay, urine, after you pass urine, and then urine, what is the content of urine? Nutrient. Okay, so you can measure for the ammonia, nitrate, and so on. So that is important to know the parameter. So the parameter that you want to measure at the certain area based on the activities. Okay, so that's why we tak perlulah, we no need to measure all the parameters. We just measure the main parameters based on the sources. Okay, that is important to know water quality parameter. So let's say this one from POME, from palm oil mill effluent. Okay, effluent, keluar effluent dia apa? Dia boleh organic, dia ada organic, ada SS. Okay, so they have the they have the ammonia. Okay, ni ammonia. Okay, ada SS, ni organic. Okay, and then they have some heavy metal. Heavy metal ni maybe the process, during the process, the press the oil and so on, so they have the involve the heavy metal. So for the POME, we need to measure for the heavy metal. For the textile, we tak perlu. We don't need, not necessary to measure for the heavy metal parameters because the process not involving the atau not use the heavy metal composition. Okay, so this is here. This is important. Why you should know water quality parameter. Okay, so water quality parameter comprises of the three categories: physical, chemical, and biological. So physical that you can sense. Okay, boleh tengok, okay, touch, okay, boleh rasa, boleh bau and so on. That is related to the physical parameter. Okay, so the typical solid, temperature, and turbidity. Okay, solid kalau nampak lah, temperature kita boleh rasa panas, sejuk. Turbidity kita boleh lihat. Okay, terbaik or not that the water. Okay, terbaik or not. Okay, keruh ke tidak water tersebut. Okay, so for the solid, we have the solid classification. So solid have the suspended solid and filtered solid. Okay, this when we filter, this one retain a filter, this one pass the filter. So the fast filter we can categorize class as the filter solid, suspended solid, okay, settable solid, and non-settable. For the passing, we can have the colloid and dissolved solid. Okay, this definition: total solid, the total all solid in the water sample that include the total suspended solid, total dissolved solid, and volatile suspended solid. Okay, TS. Okay, total solid. For the dissolved solid, the content of the calcium, chloride, nitrate, phosphorus, okay, that all the compound that pass to 2 micron filter. Okay, 2 micron meter. Okay, 2 micron meter filter. Okay, and suspended solid, silt, clay, parameter, algae. Okay, this one not passing the filter. Okay, yang passing dissolve, this one. Okay, let's say this one filter paper 2 micron. Okay, so yang passing we call as the dissolve. Yang tertahan kat sini tahan kat sini, yang mana we call as the dissolved solid, suspended solid. This one dissolved solid. Okay, dua-dua ni adalah total solid. Okay, this is the relationship. So when the sample, okay, sample here, kita filter, this one tertahan, retain, this one pass the filter. Okay, the passing the filter. Okay, so yang tertahan we call as the suspended solid, passing of the filter we call as the dissolved solid. Okay, when we go the oven, this one volatile suspended solid, this one volatile filterable solid. Okay, this is the way lah. So you can identify lah which one is the, kalau sample ni ter-evaporate aja, so this one adalah total solid. Okay, this determination of the suspended solid. Suspended solid is the one of the parameter, common parameter ataupun typical parameter yang digunakan dalam menentukan water quality. Okay, so sample, kita ambil sample kat river ke apa, transportation, go to laboratory analysis. So kita timbang filter. Okay, this one vacuum station sample. So sini kita akan letak dia punya filter. Okay, kita akan vacuum, ni akan masuk ke pump vacuum. So yang mana filter dia akan turun ke sini lah, filtrate sini, yang retain here. So yang retain here ni kita akan masuk dalam oven 108 and then 105 plus minus lah, plus minus 3 degrees. So kita tahan. So this one timbang balik, weight ni dengan weight ni tolak, so kita akan dapat total suspended solid. Okay, this example. Okay, the okay, volume. So volume 15. Okay, volume 15 millimeter. Okay, they have the data. Okay, when you want to solve, okay, related to the solid ni, to measure for the TS, TVS, suspended solid, TDS, and volatile, so you need to understand all this data. So mass of the evaporating dish. So this one dish, berat dish, weight of dish. Okay, mass of the evaporating dish, ni berat dish. Residue after evaporation at the 100. Okay, this one, this residue after ignition 550. Okay, ni kosong sample aja. Ni dish, kita letak sample. Okay, lepas tu oven tinggal here. Okay, dish sample dia lepas dia oven 550, so this berat dia. Okay, so the mass of the ni filter. Kalau filter tadi apa? Suspended. Okay, suspended solid. So 105 dengan 550. Okay, so this one akan jadi suspended solid. This one akan jadi volatile. Okay, volatile suspended solid. Suspended solid, volatile suspended solid. So kita akan boleh measure lah. So you need to understand for the each data given. So mana satu represent for the total solid. This one total solid lah. 105 total solid. Total volatile dia tak ada melalui. Kalau total, dia total solid and total volatile, sample itu saja. Sample tu dia terus kering 105. Kalau volatile, sample tu dia pergi keringkan pada 550 and then dia timbang. Tolak dengan awal dengan akhir, so dia dapat. That is the total solid and total volatile solid. Kalau suspended, yang tertahan atas. Kalau total volatile suspended, yang dibakar 105. Okey, lepas 105. Yang dipanaskan ignition 550. Tu dah volatile. Kalau 105 belum volatile. Okey. So you can compute for the total solid. Total solid. Okay, so here dish and this one adalah residual. Okay, dish dengan residual. Okay, so they have the two, dish dengan residual. So sample size, so this one is 50 meter. This is the sample size, okay, volume. Okay, so you know 1 gram equal 1000 milligram, and then 1 liter equal 100 milliliter. So you convert lah 50 milliliter, so dia jadi 0.05 liter. Okay, so unit must be in the milligram per liter. So for the total volatile solid, so the after ignition 550 degree. So kat sini dia letak 50 ml and then you ignition. So sampel yang kedua pula you letak sama, sampel yang sama dalam dish yang sama. Okay, this one 50, but you ignition to 550 degrees. Okay, so sama juga, and then you can dapat this is the TVS. Okay, for the total solid must be filter. Okay, kat filter filter after drying. Drying ni 105 lah. Okay, tolak yang filter kosong. Okay, filter kosong, and then size berapa, sama 50, and then you dapat this one ada TS. TVS, this one you drying 105, this one you drying 550, and then you akan dapat 156. So lain sama je. Okay, TVS baki dia, TDS dengan TVS baki dia. Tertinggal ni 5 nombor 6 ni. Okay, and then we proceed for the turbidity. Turbidity is the measure of the amount particulate matters that is the suspended in the water and measure of the water clarity. Okay, clarity dia. So turbid or not, okay. Measure by turbidity meter. Unit is the NTU. Okay, NTU, FTU pun ada. NTU ada, tapi common kita pakai unit NTU, nephometric turbidity units. So water that has the high turbidity appear cloudy and opaque. Okay, tebal. Okay, high turbidity can cause increase of the water temperature and decrease DO. Okay, kenapa kenapa dia akan menyebabkan temperature will be increase, okay, and decrease the DO. Okay, so the suspended absorb more heat, okay, the heat, and from solar radiation, then water molecules will, so this heat can transfer to the surrounding water by conduction. Okay, dia akan, biasalah benda yang sejuk akan pergi kepada, benda yang panas akan pergi kepada the cold medium will be transferred to the cold medium. So the cold medium, so this one we call as the conduction. Okay, such particle, clay, fine, divide organic material can also prevent, okay, sunlight, okay, reach to the into the water. Okay, decrease the rate of the photosynthesis. Okay, when the less of the photosynthesis, so the O2 of the less of the photosynthesis, so no aquatic plant in the river. So less of the O2 in produced by plant. Okay, boleh faham So bila tak ada matahari, no plant dalam inside of the water will be decrease. Plant decrease, so O2 will be decrease lah in the water. Okay, this is the temperature. Okay, temperature major factor determine which the species are present in the stream. So temperature impact the metabolism and growth of the aquatic organism. Rate of the plant photosynthesis, so photosynthesis lah mesti ada relate to suhu, and solubility of the oxygen in the water. DO 15.6 mg for the 20 degrees. So dia ada table dia ada table. Here ada table, you boleh google ke, you tengok Google DO versus temperature. So for the each temperature ni dia ada soluble, DO soluble berapa miligram per liter. Okay, so organism sensitivity to disease, okay, parasite and toxic material. So they relate to the temperature. Temperature affect the rate of the chemical and biological reaction. The more suitable drinking water are constantly cool and do not have the temperature fluctuate. So maksudnya dia consistent. Okay, contoh yang dia with the ambient temperature and must be in the ambient temperature lah, that is suitable for the drinking water. Dia tak boleh naik turun dengan kejap 26, kejap 18, 17 tak boleh. Dia not stable for the drinking water. Okay, groundwater, surface water for the water generally meet this criteria. Okay, so we complete for the physical, and then we continue for the next class for the chemical and biological parameter. Thank you.